Chapter 7 review. I am going to need my calculator running, so I better get it up and going. Desmos is not going to help me with some of these things. Forgot all about it. Have your calculators up and running too. Cleared. Some of these things I will want you to be doing by hand, and some of these things will be just fine to be done by calculator. All right, number one. Let's see what we have. Number one says, solve the system graphically, round to the nearest hundredth. Well, there you go. There's a straight calculator problem where we are asked to, maybe I'll put it over here in my recording region. Make sure you're in function mode if you were not in function mode. Try it out. Involve yourself with the stuff that's going on. That keeps you engaged in your brain learning. 3x cubed minus x to the 6. Goodness. Start out with a standard zoom. I don't know if that's going to help me or not. How many solutions? 3 solution, it appears. All right, so J. Young, your row is the first intersection. Celine, your row is the next intersection. And Sierra, your row is the third intersection. Oh, I found one. Is this right? For the first row, negative 0.74, comma, negative 1.36. Row 2, what do you have?
0.7, 0.80.
1.26. Third group?
1.40.
There we go. Write them down. So there was number 1. It would help if I looked at the key instead of a blank sheet of paper to make sure you guys gave the right numbers. Looks like you did. Number 2, solve the system by substitution. Okay? So we have a value for y. We are going to substitute into this first equation. 16x squared plus 25 times our y, which is negative 4/5 x minus 4/5, and that has to be squared, and it equals 400. I need to square out that beautiful thing out there. X squared plus 25 times. You remember how we square binomials? Square the first term, which would give us what? 16/25 x squared. Then we multiply them together times 2. So if I multiplied it together, it would be 16/25 times 2. 32/25 x. Then we square the last term, which would be, I did multiply them together times 2. Square the last term. 16/25, thanks. And that equals 400. Well, the nice thing here, when I go to distribute that 25, what happens? There they all go. So I would have 16x squared, not 16x squared, 16x squared plus 16x squared, 32x squared. 32x plus 32x. Then if I have a 16, but if I subtracted 400, negative 300 84. So I've got this thing all set equal to 0. Hey, I wonder if 32 goes in everything. 384 divided by 32. Can we factor out that 32? Beautiful. So if I factored out the 32, I have x squared plus x minus 12 equals 0. And that allows us, hopefully, to factor this thing. Does it factor? Positive 4, negative 3, so x takes on the values. 3 and negative 4. That means, well, x can be 3, x can be negative 4. What is the y that goes with it? We'll come back to that equation that says y equals negative 4/5 times our x, and if x is a 3, and then minus 4/5. See the solution we get there. Negative 12/5 minus 4 more fifths. Negative 16/5 goes with the 3. And if we put a negative 4, negative 4/5 times negative 4, subtract another 4/5. So 12/5, let's see, 16/5 minus 4, 12/5. There we go. Solution number 2. Number 3, elimination. So they are wanting us to demonstrate our ability to use these different methods. 2x minus 5y equals 6. 4x minus y equals 3. What do you want to eliminate? X. So let's multiply this one by a negative 2. I'm going to write, whoops, I don't want to draw a line there. I'm going to write my solution on that line there. Negative 4x plus 10y equals negative 12. So now when I add together these, 9y, x's are gone, equals negative 9. Y is negative 1. We can go back and substitute. Maybe I'll take that original first one. 2x minus 5 times negative 1 equals 6. 2x plus 5 equals 6. 2x equals 1. X is 1/2. 1/2 comma negative 1. I'm not sure this isn't an Algebra 2 class. See if we can take care of that. Number 4. Find the inverse of this matrix. Now, when you have a 2x2 system, I want you to demonstrate to me that you can, by hand, find the inverse. You want to check your answer by calculator, see if you did it right, and if you did it wrong, go back and do it by hand the right way. All right. Finding the inverse means I'm going to take 1 over the determinant. Remember how to get the determinant of a 2x2? Yeah. 2 times 4, 8, minus 6 times 3, 18. Times the matrix where I do some changes. Do you remember what we do with the 2 and the 4? With the 2 and the 4, you're right what you said. I change them. And what do I do with the 6 and the 3? Change the sign. All right. So that fraction in front is a negative what? I've got a negative 1/10 that I need to multiply by this matrix in order to get my inverse. So my inverse, let's see, negative 4/10, so that's negative 2/5, positive 3/10, 6/10, so that's 3/5, and negative 2/10, or negative 1/5. Is that what you got? If it's a 3x3 matrix and they ask for the inverse, you may go directly to your calculator. Oh, then show we're not done. How to use matrix multiplication to support your result. What does that mean? What's true if things are inverses?
Oh, wait, 1, 0, 0, 1, 0, 0, 1. Yeah.
That's called the identity. I get the identity when I multiply the original 2, 3, 6, 4 times the inverse, negative 2 fifths, 3 tenths, 3 fifths, negative 1 fifth. And we're going to do the second one on the calculator, but I want you to show me one. It must be both ways. Negative 2 fifths times 3 tenths, 3 fifths times negative 1 fifth, times 2, 3, 6, 4. Both of these must give us the identity when we are done. We'll do the first one by hand. We'll do the second one by calculator. So if I go to multiply here on the first one, row times column. So I'd have negative 4 fifths. And then second numbers plus 9 fifths. Sticking with my first row, second column. 6 tenths, which would be 3 fifths. And then negative 3 fifths. Second row, let's see, negative 12 fifths. Second numbers plus 12 fifths. Things seem to be working well so far. 6 and 3, 18 tenths, that'd be 9 fifths. And second number is negative 4 fifths. Which, negative 4 fifths plus 9 fifths is how many fifths? 5 fifths, 1. 5 fifths, 1. 3 fifths minus 3 fifths, 0. Negative 12 plus 12, 0. 9 fifths minus 4 fifths, 5 fifths, which is 1. Check. Calculators. Where's my calculator? So if we go to our matrix, we will have to remember we edit matrices. Once I have my matrices in, don't be lazy out there. Negative 2 fifths, 3 tenths, 3 fifths, negative 1 fifth. Oh, did it with that. Now if I multiply, B times A is what I need to do the second one. B, second matrix A. I'm going to tell it under math to go to fractions, even though we know what the answer should be. Now, when the book did it, they like to just say, oh, B times A, I don't remember if they did brackets around it or not. B times A equals identity. That's what you're doing, but you need to show it to me if you were asked to do that one, instead of just saying that one. You have to turn it in, just put it at the back. Number 5. Write the matrix equation as a system of equations. Do not solve. They are throwing points away like they were free. Negative 2, they're saying write the equation. This would be negative 2 times what? X plus 3y plus 5z equals negative 6, and etc. 4x minus 5y, well, you're not done writing, maybe you are, minus 2z equals negative 14. You see what they're talking about now?
Yeah.
That's a matrix equation that is the representation of this linear system. So we have an x, we don't have any y's, plus 3z, and it equals negative 10. That's your answer on number 5.
Yeah, what if I both two? I wouldn't have done it right.
Right? The matrix equation is a system of equations, period. Do not solve, period. You're done. Number 6. They'll make up for it. Number 6. Find the row echelon form of the augmented matrix for number 5. All right. Now I need to remember what... No, this isn't the calculator one. I need to see this one by hand. I'll let you know about some things, and you can just straight go to calculator. Remember, the augmented matrix takes the coefficients, negative 2, 3, 5, and the constants, negative 6. This is the augmented matrix. 4, negative 5, negative 2, negative 14, etc. Row echelon form. Remember what that meant? We've got that diagonal of coefficients of 1, everything to the left and below is 0, and then over to the top right we can be some other numbers. Okay? What would you do on step 1? You know what I would do? I would interchange row 1 and row 3. I get my 1 where I want a 1. 1, 0, 3, negative 10. Don't do anything with row 2. 2. Goal 1 is to get a 1 in the top left corner. If I have a 1 somewhere, just interchange the rows. I've got it. Now, I want to eliminate the 4. How would I eliminate the 4? I need negative 4 times row 1. How could I eliminate this negative 2 on row 3? Multiply it by 2 and add it. So here's what I'm going to do. And I'm going to write down what I'm doing. I'm taking negative 4 times row 1 and adding it to row 2. Add to row 2. I'm going to take 2 times row 1 and add to row 3. That will result in this. Now the first one doesn't change. 1, 0, 3, negative 10. Okay, so negative 4. Negative 4 plus 4, 0. 0, negative 4 times 0 is 0, minus 5, minus 5. Negative 12 minus 2 more, negative 14. 40 minus 14, 26. It's negative 4 times row 1, adding it to row 2. Now I'm going to do 2 times row 1. Did I get that right? Okay. 2 times row 1, add it to row 3. So 2 minus 2, 0. 0 and 3, 3. 6 and 5, 11. What do I have? Negative 20 and negative 6? Negative 26. So what I've done, I've taken that 1 and I've eliminated my numbers underneath it. What's the next thing I want to go for? Where that negative 5 is, I need a 1. How do I do that? Divide by negative 5 or multiply by negative 1/5, which is usually how we write it. I'm going to say negative 1/5 times row 2. Tell me the step you're doing. So all I'm doing is changing row 2. So number 1 gets copied, number 3 gets copied. 10. 3 is the same, 0, 3, 11, 26. And my method to be consistent is I copy down the ones that I don't touch first. That helps me eliminate any mistakes. Now, I'm dividing by negative 5. Multiplying by negative 1/5, same thing. Positive, or 0 times 0 is 0. 1. So what do I have? Positive 14/5. Double check my math. And a negative 26/5. These, you just need to be careful as you go through it, that you don't make a simple multiplication or addition error. What's the next thing I need to work on? Where the 3 is, I need a 0. So I can multiply row 2 by negative 3, add it to the bottom. Multiply by negative 3, add it to the bottom. So I'm going to take negative 3 times row 2, add it to row 3. Now, means my row 1 and 2 are done. Just recopy them. And we already have those in the form we want. Not in row echelon form, no. That's called reduced row echelon form. And we actually never wrapped around to do that final one in this instruction. All right, so let's see. Negative 3, 0 plus 0 is still 0. Negative 3 plus 3, 0. Negative 3, what's that? Negative 42/5 plus 11, which is 55/5, would be 13/5. Did I do it right? I'll let you guys check it. Yes? 13/5. You don't want to make a little mistake. All right, what am I doing? Negative 3 times negative 26. Uh-oh. 6, 18, 9, 78/5. 78/5 plus 26. I don't know. I'm going to get lost in my head on that one. Negative 208 over 5. Is that what you said? Check it. Okay. Negative 208 over 5. What's the next thing I want? I want a 1 where this 13/5 is, right? So just multiply by the reciprocal, 5/13. So the next thing I'm going to do is 5/13 times row 3. Okay, copy the first two. They're done. And what is it? 5/13. So times 0 and times 0 is still 0. 5/13 times 13/5 is 1. 5/13, the 5's cancel. Negative 208 over 13, does that reduce? Negative 16? Look at that. Negative 16. Depending on the order that you do your reduced row echelon form, you can get numbers that look different up here in that top right corner. But this will not be different because this last line means z equals negative 16. No matter the order you did it, z must be negative 16. And then if I took that negative 16 here in the z and started substituting back in, I'd need to get the same answer. So even if you do yours in a different order than I happen to do mine, or than the key might show, we can check and see, hey, is yours still okay? Is yours still correct? Did we do that right? Positive 16? No? Should be negative. I'll only need to go back and check it. My book has some, my key here has some scratches out, something different, but I'll need to check. Number 7. We'll leave it there for right now. Number 7. 7 and 8. Use Gaussian elimination to solve the system. All right. You have shown me, this is Gaussian elimination. That's what we were doing right there, getting in row echelon form. If you have shown me one of these, and you may ask me on the test, then when we get to number 7, I will allow you to go to a calculator to get it into this form right here, that row echelon form. Then I want to see by hand from that point. But let's go ahead and go to a calculator and let's enter in number 7 as a matrix. I want you to use technology, but I don't want you to be ignorant of how the inner workings of the math are. So that's why I want to mix it with still some stuff by hand. What type of matrix are we entering here for number 7? The order of it. It's a 3 by 4. It's an augmented matrix. Everybody should try this to make sure they are properly operating their calculator. Make sure they don't try to get tricky and switch the order of any of these things. What do I do after I get my matrix entered? Oh, some of you guys are racing ahead, but what do I do after I get my matrix entered? Under my matrix, I need to do my math function, my math function of REF. Row.
The other way.
If I go up, is it faster? Probably is. Row echelon form of my matrix A. Oh, yeah, I should have done that. I should have done fractions, even though we know what that fraction was. Matrix. Math. And I'm going to go the other way. Look at that. There it is. Row echelon form. Matrix A. And I want it to come out as a fraction. And we need to be able to interpret this need some more points over here. So where do I cover up? Did I get it right? Oh no. There we go. So this says, what does this last row tell me? Z equals 1. Z equals 1, depending on where you are from, maybe. Z equals 1. Negative 5/7 what? Y. No. Z. That's 1y. 1y. Y minus 5/7 z, which is 1. That's kind of nice. Equals negative 47. Okay, so we can solve for y. We'll just add our 5/7, which would be negative 35/7, which is negative 5. And I can go back to the first line, 1x plus 2/3 times my negative 5 minus 1/3 times my 1 equals negative 2/3. Did I read that one right? All right, so let's see if we can do this. This would be negative 10/3 minus 1 more, so that's negative 11/3. So if I add 11/3 to negative 2, I get 9/3, which is 3. 3, comma, negative 5, comma, 1. So we used our augmented matrix to work that one out. So let's try number 8. You guys enter, run it through. You'll probably be faster than me. I should be hearing some Yeah, this is one of those Let's see what I'm doing, what I'm getting. So even though we're using our calculator, we need some brains to go along with our calculator. So I look at that last row. What does that tell me? There's the question.
I think it's not solved for negative, but it's 0.
This means 0x plus 0y plus 0z equals 0, which means no, it means 0 equals 0. I have zeros of everything. Infinitely many solutions, which means we have more work to do. What do we do now? Yeah. Let's solve it in terms of, and I'm going to do it in terms of z. Z is going to be z. And then we're going to back up. 1y minus 9z's equal 13, which means y equals 9z plus 13. Then I'll figure out my x. 1x plus 5 force y, which is 9z plus 13, plus 7 force z equals 21 force. So just because we get our calculator, we still get to play around with this a little bit. All right, not going to try to do too much in my head or I'll get confused. X plus, that'd be 45 force z plus 65 force plus 7 force z plus 21 force. Now I'm going to try to solve for my x. See how good I do. 45 z, force z, and 7 force. What's 45 plus 7? 52. So if I subtract, what's 52 force? 13. 13. That's 13z. So if I subtract 13z to bring it to the other side, then what do I have? 65 force, which I need to subtract. So 21 minus 65, 44. Negative 44 force, which is? Negative 13z minus 11. What would that last row look like if there were no solutions?
0 equals 9.
Maybe it's a 5 and a 0, or 0 and a 9. So when I have no solutions, the last row may be 0, 0, 0, 7. That would be 0 equals 7, or etc. So make sure you can interpret it to know, hey, there are infinitely many, or there aren't any solutions on this one at all. Number 9. They kind of regress. Not sure why they jump backwards on this one. Perform the elementary row operation. 2r sub 1 plus r sub 3 on the matrix. Well, let me copy the matrix so I know what I'm going to be doing here. 3, 7, negative 2, 1. I mean, we just got through earlier doing a whole bunch of these things. So, like I say, every once in a while on this test, they're just going to throw points at you. Don't miss them. 3, 7, negative 2, 1, negative 2, 4. Preaching to myself. They're throwing points at me. Don't miss them. Negative 2, 4, 1, 5, 2, 8, 9, negative 3. All right, so we are supposed to do 2 times row 1 and add it to row 2. 2 times row 1, add to row 3, sorry. And add it to row 3 down here. Now, what does the first line of my answer look like? Stays the same. 3, 7, negative 2, 1. 3, 7, negative 2, 1. What is the second line? Stays the same. Negative 2, 4, 1, 5. And now we finally do a little bit of math. 6 plus 2, 8. 14 plus 8. How much? 22. Negative 6 plus 9. Negative 4 plus 9.
Yeah, that's it.
Wow, I'm really trying to miss those points, aren't I? 2 minus 3. Well, don't get so excited like me and mess up your multiplication and addition and miss those points that they're throwing at us. Number 10. Here's some more points. Dropping like money from heaven. Write an augmented matrix for the system of equations. Oh, then we have to do some stuff. Then use elementary row operations to obtain the reduced row echelon form.
They do that.
They do it. They didn't do it in the instructions. Negative x, I think they did one in your homework maybe. Oh, I don't want the x's and y's. Yes, ma'am.
Go for me then.
Yes, ma'am. All right, did I copy this one all right? I think I copied this one all right. Then use elementary row operations to obtain the reduced row echelon form. Well, let's start what we normally do. Get those diagonal of ones, which means how will I begin this one? You're multiplying by negative 1 on row 1 is what you're doing. Negative of rows of 1. 1, negative 2, 7, 10. This is an exercise in careful patience. So don't get anxious. Good things come to those who slowly and carefully work their matrices. And your teacher might look back at the work. It's interesting how this all starts wrong, but the answer's right. What do I do next? I want to eliminate this 2, and I want to eliminate that 3. I'm going to do both of them. So I'm going to take negative 2 times row 1 and add it to row 2. Negative 3 times row 1 and add it to row 3. So row 1 is done, at least at the moment. All right. Negative 2 plus 2, 0. 4 plus 1, 5. Am I doing negative 2? So negative 14 and 3. Negative 20, 19. Negative 3 plus 3, 0. 6 plus 10. Negative 21 minus 1, negative 22. I'm doing negative 3, negative 30, and 7, negative 23. Are my numbers and your numbers in agreement?
It should be negative 1. Negative 2 times.
Where's my negative 1?
Negative 3 plus negative 1.
I don't know where you are in the thing.
Negative 10.
Under the 10? Oh, the 1 should be a negative 1?
Yeah.
Negative 20 plus 19, negative 1. Thank you. Now are we in agreement? Okay. Next, what do I want? I want a 1 where that 5 is. I'm going to take 1/5 times row 2. I want a 1 where the 5 is. 1, negative 2, 7, 10. Last one, 0, 10, negative 22, negative 23. 0, 1, negative 11 fifths, negative 1 fifth. It's multiplied by 1/5. You need to get rid of that 10, so it will be negative 10 times row 2 and add it to row 3. Negative 10 plus 2 is 0. Negative 10. All right, so that goes in negative 2. 22. Minus 22. Ooh, did that just happen? Negative 10. So 10 fifths, which is 2, minus 23. Check my math there. We're done. I can do nothing with this thing. Number 11. Well, as long as you did number 10 right, you're good for number 11. Give the number of solutions to the system. Okay. 0 solutions, I guess, would be the proper way of answering that. There aren't any. 12. Use inverse matrices to determine the coefficients of the function. They give us this third degree. So that the graph, and they give us these 4 points. So in other words, they want us to figure out the equation, this third degree equation that goes through these 4 points. You always have to have one more point than the number of degree to figure out the equation. And that's what they've done here. And we will use our calculators to help us out. And we'll use the method that they want us to do. What am I doing with this point negative 2, negative 8? I'm substituting it into this equation. So x is negative 2. So how many a's would I have? Negative 8. A. Negative 8a. And then how many b's? 4b plus 4b. Then minus 2c plus d equals, I've kind of turned it around, negative 8. The function is negative 8. 1, 1. Equals 1. All right, help me out. A plus B plus C plus D. There it is. 337. Well, I know it equals 37. 27A plus 9B plus 3C plus D equals 37. And finally, 125. 125A plus 25B plus 5C plus D. So I have my system. How did they say they wanted this solved? Inverse matrices. Now, I want to set this up with what we are doing. We are going to have the coefficient matrix, negative 8, 4, negative 2, 1, 1, 1, 1, 1. I've got enough lines. What am I needing to do with this? Inverse of this one times all right. Well, some of you were paying attention, following along with me, and some of you already have the answer, but let's see. Got a 3 by 4, 1, 2, 3, 4 by 5. 1, 2, 3, 4. Oh, it is 4 by 4. Hopefully it kept all my numbers. Oh, there's a D. Is that where I put it? All right. Evidently I put it on D. Actually, I want to go look to make sure. All right. Hey. 4 by 1 is that other thing. The inverse, hopefully I entered it. Is that what you got or not?
No, it's like, wait, did you put it, did you say?
I did the inverse. I think I entered mine in D.
Yeah, union D, man. Yeah, that's what.
Oh, never mind.
Is that right? Is that what you guys are getting? We're going to look at the answer in a minute. The function is supposed to be, oh, they just say what A, B, and C are. Well, that's no fun. A is 1/2. B is 2. No, those are bracket. C is, I want to be consistent, 0.5, 3.5. D is -5. The book seems to agree with me. That would be the third degree function that would happen to go through all those points. We used an inverse matrix to help us solve it out. Again, look back through your work on all the different examples and the kinds of problems that we did through the chapter. Don't just be stuck with this. I want you to go check something. Remember there was one of the, oh, we're not done. 13. 13. Forgot the third page. Write the system of equations that arises when finding the partial fraction decomposition of. Do not solve. Well, we'll make sure we understand what they are meaning by this. Well, I first need to factor this denominator, don't I? X cubed plus 3x plus 1. Maybe I should just start working on that. That might take us a little while to factor this thing. What can I factor out? I can factor out an x squared, can't I? So it would be x squared plus 2x minus 3. And so if I factored that one, does it factor? X plus 3, x minus 1. We got it. So I'm going to put that numerator back with it. X squared plus 3x plus 1. So now work on my partial fraction decomposition. Ooh, what do I need to do with that x squared? I have an x, something over x, a sub 1, a sub 2 over x squared. We need two of them there. X plus 3, I'm going to move to my next letter b over x plus 3. And I'll move to my next letter c to go over x minus 1. That's not all. They said they want the system of equations. In other words, we're not going to solve that last system, but we're going to take it all the way to get the system of equations that would be used to figure out what the A's 1, 2, B, and C are. So I need to multiply by our least common denominator still. X squared plus 3x plus 1 is on the left side. Wow, that doesn't get rid of very much, does it? I'm going to remember that those binomials multiplied together is that trinomial. So 1x is canceled. So it's a sub 1x that I distribute. So a sub 1x cubed. And a sub 1, or 2x squared. 2a sub 1x squared. Then minus 3a sub 1x. Now the x squared one, the x squareds would be gone, and it's a sub 2 times that trinomial. So that's not so bad. A sub 2x squared plus 2a sub 2x minus 3a sub 2. I probably was writing too large, it appears. Now, when I get to that b term with the x plus 3, I've got to go back to these things where they're all factored. So I have a bx squared that needs distributed. So bx cubed plus bx cubed b minus bx squared minus bx squared. Same idea on that x minus 1 term. Cx squared times x plus cx cubed. Cx cubed minus cx squared. No, minus 3x plus 3c x squared plus 3cx squared. Put the 2 in the wrong spot. Plus 3cx squared. That's our last thing, isn't it?
Yeah.
All right. Now.
Like that?
No.
More work for the
We're almost.
except she's grading it, so that's fun.
Yeah, I'm grading this one. All right, our x cubes. I've got an a sub 1 plus b plus c. Is that correct? X cubed terms? X squared terms, I have a 2a sub 1 plus a sub 2 minus b plus 3c. Those are all the x squared terms. X terms, minus 3a sub 1 plus 2a sub 2. X, that's it. X terms. Do I have any constant terms? Oh, I do. So that minus 3a sub 2, the only one. Now will be our answer on the next step. The system of equations are, what about my x cubed term? What about my a sub 1 plus b plus c equals 0? There's 0 x cubed term. 2a sub 1 plus a sub 2 minus b plus 3c equals 1. We're writing the answers is what we're doing. Negative 3a sub 1 plus 2a sub 2 equals 3. Negative 3a sub 2 equals 1. They said that's all we need to go. Find the system of equations that arise. There they are. Man, we've gone so far, you hate to stop. 14. Find the partial fraction decomposition. Oh, but they made it an easy one where we have to do it all. Of course, the test won't, right? Next one, hopefully. All right, we need an x plus 1. And we need an x minus 1 term. So that's Pretty straightforward. X plus 1 and an x minus 1. Take the time. Write it all out. Don't try to skip a bunch of steps. That's where it's easy to make little silly mistakes. 2 equals, let's see, if my x plus 1 is gone. Ax minus a. Minus 1 plus bx plus b. Am I good so far? All right. So 2 equals a plus b are my x terms, and negative a plus b are my constants. So my x term, what does my a plus b equal? 0 on the left. And my negative a plus b equals 2. Hey, I can add those together. 2b equals 2, b is 1. If b is 1, a plus 1 is 0, a is negative 1. Negative 1 over x plus 1 plus 1 over x minus 1. We decomposed it. And we could have done 13 too. We could have solved for our a sub 1, b sub 1, or a sub 2, b, c, d, x, y, z, whatever. We could have done that. 15. Graph the inequality or system of inequalities. They threw something at us that's old and is going to be new again. We're getting ready to go into conic sections the next chapter. But do you remember all the way back to Algebra 2 where we actually graphed some things like this? This is an ellipse. A circle would look something like this. X minus 4 squared plus y plus 2 squared equals 4. That would be a center of 4 comma negative 2 and a radius of 2. 2 squared is 4. Circle is like that. An ellipse is where it equals 1. It's an inequality, less than or equal in this case. But we have these fractions that equal 1. And on the ellipse, this is all the way back to last year we learned this. That's called the semi-major axis, half of the long way on the ellipse. And this is the minor axis, half of the short direction. So, if you weren't here last year, you may not have seen one of these before. If you were here last year, you have seen one of these before. And this is the 16 must be the big number, but that's squared. A is 4. The long way is 4. And that 9 is the B. It's a smaller. It's 3, because 3 squared is 9. And since it's just the x squared and y squared, it's centered right at 0, 0, right at the origin. And that's, I don't remember if we moved them around in Algebra 2 or not. But it's right at the origin is all this is. So I just need to go a direction 4 in the x direction, right and left. Right and left. That's the major axis of my ellipse. And I go 3 up and down. That's really just to the side of my ellipse. Oh, I started drawing a solid line. But this is an inequality. Is it a solid line? It is. It is less than or equal to. But where is the less than or equal to part? It is inside. You can always use a test point. Remember I talked about test points on these inequalities? You can always use a test point. Pick a point. I'm going to pick 0, 0 because it's really, really easy. 0 over 16 is 0 because 0 squared is still 0. Plus 0. 0 plus 0 is 0. Is 0 less than or equal to 1? Yes, it is, which means everywhere inside this. Now, I'm not going to shade it yet because I have a second equation to go with it.
This is system on B, there's just one on
So just one on A? Oh, there is just one on A. Now I'm going to come back once we finish up and we'll look at a graphic calculator. It's not the easiest way to enter, but it can't be done. B. Yes, Desmos is something else. You don't have to do any arranging in Desmos. It recognizes it and says, ooh, here's how it goes. B, 2x minus 3y less than 6. Y is less than, I'm going to change the order of this one a little bit. Negative x squared plus 4. Let's do the second one. What is that shape? Parabola. It's reflected across the x-axis and it's moved up 4. So I have a vertex right up here and it's opening down over 2, 1, 2, 3, 4. It's opening down. And it is a non-solid line. I like dashed lines. You may prefer dotted lines. And the inequality, if my y values are less, I would be where? I'd be inside that parabola. I'm below that vertex. Y value is below that vertex. I'd be inside, so I need to stay inside that thing. Now I'm going to do this one, which is, what shape is that first equation? That's a line. Let's see, negative 3y less than negative 2x plus the 6. Y, help me out. Greater than, very good. We just divided by a negative. Positive 2/3 x minus 2. So negative 2 is my y-intercept. What is it, 2/3? Up 2, 1, 2, 3. And it is also a dashed line. And we are supposed to be where? Yeah, above this line and inside that parabola. So there we are. Sixteen. Solve a linear programming problem. Maximize 12x plus 5y, subject to. I'm going to take that first equation and solve for y. So I'd have to subtract my x and divide by 4. I go 4x, divide by 4, plus 8. All right? I took the second one and solved for y. I'd have to subtract 7x and divide by 3. Oh, 49 divided by 3. How inconvenient. 49/3. And then we're first quadrant. We're going to go to our calculators, since that is what you will have available on the test. I hit my window. Not sure how far the X's are going to go. I'm going to try 15. On your X's? So let's go to 30 on our X's. Now my Y, 49/3. I'm going to go to 20. My Y. All right, so there's my plus 8 one. Oh, well, yeah. I'm enough, even though that first one went way over to the right, I'm below it, and I'm also below the steeper one, so I'm over here in the first quadrant in that little corner. So we're in this region right here because we're supposed to be less than all of them. So I've got 1, 2, 3, 4 vertices. One of them is 0, 0. That was nice. That's this one right here. What's that one there? That 0, 8. That's 0, 8. 4, 7 is the intersection, which you can find either intersection of the graph or substitute and solve by hand. And now we need this one down here. Now here's an easy way to do it. That's the real steep line. That's this one. That's where it equals 0. You can use your calculators if you want. 0 equals negative 7/3 x plus 49/3. So I get 7/3 x equals 49/3. X equals 7. Is that right? 7, 0. It's the 0 of it, where the equation equals 0. And we put it into our objective quantity. First one will be 0. Let's see, 0, 5 times 4 is 40. 48 plus 35. 83, double check. 84. Are those the right numbers? Maximizing, is that what they wanted? Make sure you solve a linear equation problem. Maximize C equals subjective 2. There it is. And now they say C equals 84 at 7, 0. Boy, that bell is going to ring. But here is the only way on your calculators you could graph that equation. You have to solve for y. And since it's y squared, you'll have y equals a positive square root and a y equals a negative square root, which will graph the top half and bottom half of that ellipse.